Hi and welcome. This video serves as an introduction to a C# advanced course. When creating the tutorials for this course, I'm going to assume that you have a certain amount of experience using the C# language, or at least one of the other C-based object-oriented languages like, for example, Java or C++. Of course, anyone at any level is welcome to follow along with the upcoming advanced C# tutorials, but if you are completely new to programming or C#, I recommend going over the free C# for Beginners course provided by this channel, before going through the tutorials created for this C# advanced course. A link to the C# for Beginners course playlist is provided below in the description. So, what sort of topics do I intend to cover in the C# advanced course? Here are a few examples: delegates, events, generics, extension methods, lambda expressions, LINQ, asynchronous programming with async await, attributes, reflection, and more. So, what makes these kinds of topics more advanced than those discussed in the C# for Beginners course, where we covered basic concepts like methods, classes, arrays, data types, variables, enums, switch statements, if statements, loops, etc. If I had to pick one word that sums up the answer to that question, that word would be the word abstract. I've found what I believe to be an appropriate definition for the word abstract that in my view best fits the programming context: to consider apart from application or association with a particular instance. This definition sort of reminds me of the ancient philosophical theory or worldview attributed to the great ancient Greek philosopher Plato. This theory is known as the theory of forms or theory of ideas. I'm not going to go into too much detail regarding the theory itself, but basically the theory asserts that ultimate reality exists outside our temporal and spatial world. For example, the human form itself exists as a thing independently from the actual humans that exist in plural in our experience of our temporal and spatial realm. An even more simple example is that of the shape of a triangle. If I asked you to draw a triangle and I was to also draw a triangle, there would be subtle differences in our drawings, but essentially we would both be able to recognize the three-sided triangle shape in both of our drawings. There are forms that are universal. So in this sense, the triangle shape itself can be seen as an abstract concept, but instances of this shape can be found and recognized in our real-world experiences. So, for example, in terms of programming, we have certain abstract concepts that exist on their own as universally recognizable patterns. These patterns can be implemented in our code to solve multiple real-world problems. It can be hugely advantageous to understand certain advanced abstract concepts that can then be appropriately applied in code to achieve better code reuse, cleaner code extensibility, flexibility of design, easier maintenance of code, separation of concerns, enablement of effective unit testing, and the provision for overall better performance and efficiency of our applications. If there is one downside to the implementation of certain advanced code patterns, it is that to someone unfamiliar with these advanced concepts, the code implementations of these advanced concepts can appear as somewhat esoteric. For most people, the more abstract a concept is, the more time is needed to understand the abstract concept. This, I would say, is the main difference between the concepts discussed in the C# for Beginners course and some of the concepts that we will cover in the C# advanced course. Let's look at a basic code example. So this is just a basic example that I'll go through fairly quickly. It's not necessary to follow along with the example. I will, however, make the code example available on GitHub. Please see a link to the appropriate repository below in the description. So let's create a C# project based on the .NET Core Console Application project template. Let's name the project School HR Administration. Let's create a class library project and I'll name this HR Administration API. Within the class library project, let's first delete the class that is there by default, and then add an interface named iEmployee. Let's add 4 property definitions to the iEmployee interface. ID as integer, first name as string, and this is an interface, so we of course don't need these public access modifiers preceding our property definitions. Last name as string and salary as decimal. Let's add an abstract class and name it employee base. Let's make this employee base abstract class implement the iEmployee interface. And let's make the salary property a virtual property. So now we have the basis in our HR Administration API class library project for a basic employee record. So from within our school HR Administration.NET Core Console application, let's make a reference to the HR Administration API class library project. Let's create a class named Teacher, and let's make the teacher class inherit from the employee base abstract class. Let's ensure that our code includes a directive to the HR Administration API namespace. Let's create 3 other classes that inherit from the employee base class. These classes represent some other staff roles within the school. So, head of department, deputy headmaster, and headmaster. Let's say there is a requirement to sum up the annual salaries, including bonuses, for these members of staff. First, let's create a method named seedData. So the seedData method accepts a generic list which is strongly typed as iEmployee as an argument. Let's instantiate 5 employee objects and add each of the objects to the employees collection. For the sake of this example, I'm going to hard-code the property values for these 5 employee records. So let's say that a bonus is paid annually to each of these staff members, and the amount is based on seniority. So let's override the salary property and add an appropriate bonus for each of these employees. Let's say the teacher gets 2%, the head of department 3%, the deputy headmaster 4%, and the headmaster gets 5%. So let's address the requirement to calculate the sum total of staff salaries, including bonuses. So to do this, we can implement a for each loop in the main method that traverses the items in our employees list and sums up the salaries within the for each loop using the plus equals operator. We can then output the sum total of all staff annual salaries, including bonuses, to the console screen. Let's run the code. Great. We can use more advanced code to achieve the same thing literally through writing one line of code instead of the multiple lines of code used to create the for each loop and the mathematical operation performed within the for each loop. So let's include a directive at the top of our code to the system.link namespace. By using the LINQ technology, we are able to provide the same solution with one line of code like this. Let's run the code. And we get the same result as before, but our code is more concise and much cleaner. So let's briefly look at some of the advanced C# concepts that have been applied in this simple example. My explanation at this point will be brief because each of these topics will be discussed in detail as the C# Advanced course progresses. Sum is an extension method provided in the system.link namespace. Let's see what happens if we comment out the system.link directive. The C# compiler immediately complains. The system.link namespace contains many useful extension methods, including the sum extension method. A lambda expression is passed into the sum method. The sum parameter accepts a delegate argument where the delegate contains a type definition parameter, i.e., the iEmployee type. And as you can see, there are several overloads to the sum method where the output type of the delegate can vary. So we are passing in a delegate that accepts an argument of type iEmployee and outputs a decimal value. So because we are summing up the salary field and the salary field is of type decimal, the delegate passed in the form of a lambda expression, has an output of type decimal. Notice the func keyword is used to define the delegate type parameter. Also notice the angle brackets following the func keyword, and within the angle brackets, the dates type definitions are included. This is an implementation of generics. Even in this really basic example, a lot of complexity is abstracted away through the use of technologies like LINQ, extension methods, delegates, lambda expressions, and generics. I won't go into too much detail explaining these technologies in this video, because all of these technologies will be explored in detail in this course. Here is a brief definition of each of the technologies we have just discussed. LINQ stands for Language Integrated Query. LINQ enables the developer to write queries against strongly typed collections of objects by using language keywords and familiar operators. Extension methods enable the developer to add methods to existing types without creating a new derived type, recompiling, or otherwise modifying the original type. A delegate is a type that represents references to methods with a particular parameter list and return type. A lambda expression is a shorter way of representing an anonymous method using special syntax. The func type provides a way to store anonymous methods in a generalized and simple way. Generics introduce the concept of type parameters to the .NET framework, which make it possible to design classes and methods that defer the specification of one or more types until the class or method is declared and instantiated by client code. Let's abstract the object instantiation process for an employee through the use of a factory class. So we are going to implement the factory design pattern to implement this code. Let's first create an enum at the top of our code and name it employee type. Let's include the members of staff employee roles within the context of a school in the enumerator list. Okay, let's create a public static class named employee factory. Within this class, let's create a public static method named getEmployeeInstance that returns an object of the iEmployee type. Let's implement the code for this method, which simply instantiates an appropriate object based on the type of the employee. Let's write the code that returns the employee object to the calling code. Right, let's use our factory class to construct our employee objects within our seed data method. So we have now abstracted the construction of our employee objects. Let's run the code. But now let's go one step further. So within the HR Admin API class library project, let's create a generic class named factory pattern. As discussed earlier, to someone not familiar with generics, this class may seem somewhat esoteric. The method in this class instantiates an object generically. Even though the object is generically created, generics enables the code to be strongly typed, and therefore the code is checked at compile time. So let's go back to the calling code in the school HR administration project, and in the employee factory class, let's update the code that instantiates our employee objects through the utilization of the generic factory pattern class. We have abstracted the object construction process even further. So let's run the code. Great. So before I conclude this video, I want to highlight another reason why it is important to understand the more advanced concepts in C#. These advanced concepts are commonly used in various .NET project frameworks, like for example, ASP.NET MVC, Web API, and Xamarin. If you are a game developer that uses the Unity game engine, knowing the more advanced concepts in C# will also be hugely advantageous. You could create code for each of these types of applications or games without having a deep knowledge of the advanced concepts that are built into the frameworks or game engine themselves. But having a knowledge of these concepts is going to give you an advantage when building and maintaining your applications or games. So, for example, behind the scenes, as it were, reflection is used extensively in ASP.NET MVC. For example, when the controller and action names are passed from the root, reflection is used to find the corresponding method to invoke. Attributes are also used extensively to abstract away complexities and facilitate the reuse of common functionality. Asynchronous programming with async await is used here to increase performance. And generics is also commonly featured. With the Entity Framework data access technology, lambda expressions and LINQ are commonly used. Entity Framework is commonly used in ASP.NET MVC applications and Web API applications. In the Web API framework, we see the same technologies being applied. Note that dependency injection is a built-in feature in the ASP.NET Core MVC and Web API project frameworks. Dependency injection will be explored in the C# Advanced course. In this Xamarin project, we can see here the use of attributes and generics is being applied here in code. In this game created with Unity, generics is commonly used. Attributes are also frequently applied. And these are just a few examples of how these advanced concepts are applied in commonly used project frameworks and the Unity game engine. In summary, what makes a concept in programming a more advanced concept? The more abstract the concept, the more difficult the concept is to understand for most people. Gaining an understanding of the more abstract advanced concepts can be applied to achieve better code reuse, cleaner code, extensibility, flexibility of design, ease of code maintenance, separation of concerns, the enablement of unit testing, and the provision for overall better performance and efficiency of our applications. The more advanced concepts are applied frequently in the various .NET project frameworks, like for example, ASP.NET MVC, Web API, and Xamarin. Understanding these advanced concepts will also be an advantage to game developers that create games using the Unity game engine. Some of the advanced concepts that will be explored in detail in this advanced C# course will be, for example, delegates, events, generics, extension methods, lambda expressions, LINQ, asynchronous programming with async await, attributes, reflection, and more. If you haven't already subscribed, please consider subscribing and ring the bell to receive notifications of upcoming tutorials on advanced C# concepts. If you feel you have benefited from viewing this video, please hit the like button. It will be greatly appreciated. Please feel free to share my videos with anyone you feel may benefit from their content. The code created in this video can be downloaded from GitHub. Please see a link to the appropriate repository below in the description. Thank you and take care.